Go.
I did it.
Here, I got it. Start recording.
Okay. All right. Well, good evening, everybody. Welcome to the August 2021 Chicago Data Professionals meeting. Tonight, I would like to introduce you to David Keeshin, who will be speaking to us tonight. He's spoken to us before about a really cool project that he worked on tracking COVID-19 data. And what I like is when David comes to us with some type of presentation idea that he has, it's like this full-on solution and project. And it's really cool to listen to somebody talk about how they tie all these things together. Because oftentimes I think in the user groups, we're learning about a feature or how to troubleshoot something and not as much about a solution. And that's why I like when David comes and talks to us here. So a little bit more about David, right? He is a data and application architect and an expert in database administrator and a founder of his KDS or Keeshin Database Services, right? Do you go by KDS or Keeshin Database Services?
KDS is fine.
All right, so KDS LLC. And he's done a lot of work and engagements over many years. 23 years completed engagements with financial services, technology, manufacturing, marketing, and human resources. And so I would really like to welcome David tonight to talk to us about OLTP 2.0, an open source peer-to-peer network of databases, which is really cool, using best of breed components like Linux, Postgres, and some other open source stuff. So this is going to be great. So take it away, David.
Thank you, Jared. I'm going to need to share the screen. I don't see that option on my. It's under more actions, or do you have to give me the?
Do you see some ellipses?
I see.
On
no.
You don't see.
I think the problem may be because you're a guest, and I don't know. Let's see, Ross, do you have the? I think you have the meeting options. I don't have that. So if you can go to the meeting options and maybe add him as a presenter.
Yeah, I think you're going to have to do that.
Well, I think I've got everyone as the presenter.
Oh, I got the open share tray. Hold on.
Okay.
I think we can do it. I'm doing my found it. So I think I'm going to desktop, right?
Yeah.
Yes.
All right. Can people see that now?
We can. We see. How do you want to join the Teams meeting? So
yeah,
good
okay.
to go.
All right. We're now good to go. I'll do my little. What happened? Nothing.
I think what I found that I had to do with Teams is to you got to when you share, you have to share a particular application.
Oh, really? I can't.
Yeah.
Even if I'm running it on the desktop?
Yeah, you won't have to, but
you see this?
A different way. So we can see this.
All right, yeah.
Yeah, this is cool.
All right, let's go from the beginning. Okay. Again, thank you, Jared, for the nice introduction.
Hey, I actually worked on that.
That might be you. That might be a picture of you, Ross. Yeah. In any case, it's actually been a year since I did that presentation on COVID-19 data management. I'm laughing, but it's really no laughing matter, I suppose, because if any of you attended that, I built a data management solution for tracking COVID-19. At the time, it was just cases and deaths, and that's before there was even a vaccine. And I used the Azure SQL database and some other microservices, and I described the approach that I took, and it actually is still running. I stopped using Azure SQL database to keep the costs down, and I'm still using it. I'm still running the application, that is, and it basically is just generating data from the sources that I had mentioned last year, and it's outputting CSV and JSON files, and it's going to the GitHub site, right, located right here at the bottom of my background. So if you're looking for some COVID-19 formatted data, it's still there, and it gets updated. It gets updated nightly, and obviously in December I added the vaccine data to it, so it's unfortunately still running. In any case, Jared very concisely described my experience and my background. And I'm a data architect and developer and a SQL Server DBA. I've been doing this for 35 years. The past 23, I've worked in a variety of areas: financial services, technology, manufacturing, distribution. And I've worked for all those nice companies that have listed on my page here that have helped pay the bills. KeeshinDS.com is my website. All right, so again, I talked to Jared just briefly about this proof of concept work that I've been doing. And I guess the best way to describe it is a network of databases built around a data event-driven pub-sub architecture. Because it really is a pub-sub architecture. There's publisher and subscriber. If anybody's worked in that area before, you may know what I'm talking about. Hopefully, when we're done tonight, you'll have a better understanding how that works. As you can see from my little animation there, the approach that I'm taking is a database everywhere approach, so that each peer on this network basically has its own database. Now, again, in the SQL Server world, that would be hard and pretty expensive to do. So that was good reason to go to open source. The idea is to have a data event-driven, permissioned network of databases for near real-time use. This solution right now pretty much needs to live on the inside of a firewall. I treat each database transaction as an asynchronous message, which when you're doing asynchronous communications is pretty much a given. I'm trying to achieve reasonable and eventual data consistency, which in the case of a real-time, and I often use the term near real-time because, as we all probably know, real-time really doesn't exist. Although I guess what we're doing right now is real-time, but that may not exist. In any case, the idea is to achieve reasonable and eventual data consistency, which is really a practical way of trying to keep all those databases that you may have running in a network like this up to date. Factor distances and speeds between peers into the design. This is something I see a lot of, and I have in the past, and it probably is the fault of the data architects, not so much the network architects, whereas you have to factor, especially in certain application financial systems, anything that's really dependent on performance, that, you know, the farther the distance is, you know, in theory, the longer it's going to take to get somewhere. I am borrowing from the blockchain here, and that is I'm making transactions immutable. Basically, inserts only. It's kind of like a type 2 dimension in a dimensional model where you just add a row. So that can certainly make things a bit easier. and make it easy to understand, use, maintain, and customize. The pub sub pattern is pretty simple concept. So those were sort of the parameters that I set for myself for investigating this. Again, then I had to sort of pick what tools I was going to use. And my approach often in design is to try to match or try to merge, or I would say assimilate. That's a better use. Assimilate, some of the things that work well with things that are looking forward. And that is what I did here. So I'm trying to take the best of relational databases, asynchronous messaging, which is a given, and even blockchain to some degree. As far as the actual tools, again, I tried to pick, after investigating a lot of different solutions. If you go to my website or to my blog on my website, at the end of it, you can see all of the references to data systems, programming tools, newer emerging technologies, everything. And this is what I came up with at this point. And again, trying to stay in the open source world because of some of the licensing restrictions that would be a problem if you're trying to do this in a proprietary software environment. So it's basically a Linux, PostgreSQL, Go, and gRPC solution or proof of concept that I built. Linux, I'm assuming, I suppose I'd like to see a show of hands to see how many companies and organizations are currently using Linux. And I would say it seems like a lot. And here's some of the reasons given often for Linux, and also probably for open source. But one, it runs on older hardware. Now, I've worked for a number of companies that basically have a policy for repurposing servers, for instance. And I think when I think back about that, I go, at the time, it was probably a good idea. But if you look at the number, you see the amount of e-waste that's going on right now. I think companies and organizations are going to rethink that to some degree. Because Linux basically can run on anything. It's community supported. I did an interesting search. I wanted to see how many developers are building Windows at Microsoft, and I got a number, which is roughly about 15,000 engineers are running it or building Windows at Microsoft, versus about the same number of people that are responsible for maintaining the core in Linux. So I guess Microsoft's catching up. If you've used Linux, people say it's more flexible and easier to customize. Security, I guess I really should put here, maybe it's hacked less. Now, again, that could be a numbers issue, but you don't really run into the security and the data breaches that you often find, on the Windows side of things. And all this, it avoids vendor lock and expensive license fees and conflict. It's free, so your cost of ownership is low. Again, I've been at Windows, working in Windows for almost 30 years. And the last 2 or 3 years, I just started looking at Linux and found it very very accommodative, and it's definitely worth a look if you haven't used it or are not using it in your organization right now. But it definitely has a role, and you can run SQL Server on Linux too, which was something that I didn't think I'd ever say for a long time. PostgreSQL, as I try to pronounce it, it's been around for a long time. It competes with SQL Server to some degree. Excuse me, I have to take a drink of water. It dates back to like 1986. It's ACID compliant, and for the work that I wanted to do here, it has built-in asynchronous capabilities like listen and notify. Otherwise, if it didn't, I'd have to go to another product or solution. So that being said, that gave me the reasons to use it, and I've used it in a couple other situations in the last 2 years, and I like it. Go, designed by Google in 2007, still widely in use there. I read about it, and it was developed as a response to the criticisms of C++. And at the same time, the designers of Go wanted high performance, usability, and you get all that with Go, and it also integrates easily with gRPC, which also has its roots at Google. Stubby, which was derived from a RPC that was used by Google to connect a large number of microservices running in Google's data centers. RPC has been around for a long time, and that goes back to the into the 1960s. In 2015, Google decided to build the next version and open it, and then make it open source. Again, I would like to see a show of hands, if I could, if anybody's using gRPC. Is anybody can anybody talk to me and say if they are? Let me see here if there's anybody out there that's using gRPC in their organization as an API. I assume that I didn't hear anything. Is no.
We're using PostgreSQL if that counts.
Okay, no, that's fine. I'll give you half credit there, Ross. Is that Ross?
Yes, it is.
Okay. This next item is a big one. Oop, let's go back. This item is a big issue or advantage of gRPC because it uses what they call protocol buffers, and it's for sending, receiving non-readable binary data messages. So basically, it eliminates the need to serialize and deserialize messages like XML or JSON the way REST or SOAP APIs require. So that being said, it makes it much faster. It runs on HTTP2, which was introduced in 2015. HTTP2 is a revision of HTTP1, and all browsers now support it, and it gives you the features like bidirectional communication. There was one other one I can't remember off the top of my head, but in any case, it does require HTTP2. Google, obviously, Square, Netflix, Cisco, and others use it. And gRPC.io is the website. And the documentation is actually pretty good. Okay, so for this little proof of concept, well, I should say little because it's really not that little. I decided that I would control the publishing side of the pub sub pattern using a data store or Postgres, and this is the basic model. I'll try to see if I can make this a little larger. Basically, it's pretty simple. This hub profile table is the table that is you or your server. And then these are all your locations or your, I'm using IP address, and I think probably not a good idea to use the IP address potentially as a primary key, but for the purposes of demonstration, I did. But these are just the members or the hubs in your peer group that you can communicate with. And then this is just joined by a route, which is just the join between the hub profile and the hub peer group. Okay. And I do use a location table. And you'll notice it's just a latitude and longitude in there. It's always a good way to do this because you can always get that latitude and longitude from somewhere else. And I do assign an ID here that's not obviously an IP, but I hash the latitude and longitude. So it is unique. So that being said, that was basically the data model I was going to use to manage the proof of concept. I think I'm just going to, I don't want to go through this whole flow chart. Basically, let's go back one. What I'm going to do for the demonstration, or what I will demonstrate, is this location table, which is like a reference or a lookup table, obviously. I wrote the code to insert data into that location table and then populate it through for the network. So it'll get loaded into a local workstation right here, and then it'll use. Let's just go. Let's see. This is probably easy. I'm going to insert this a location into a table, a stage.location table, and it's going to fire off a trigger in Postgres, which Go is going to hear, and Go is going to then look up those peer group hubs. It's going to sort them by IPs randomly, and then send a notification and the payload, which is this insert, to these remote locations, servers. And this is being done over gRPC. And Go will then, as part of the gRPC connection, will then send a message or return a message back to my local workstation, and it'll then populate the reference version of this location table. Any questions? All right, we'll get to this. Let's go. So a couple things to note. I'm using a product to remote to my Linux workstation. It's called No Machine. It's really good. So if you're looking to do this kind of thing, think about that product. And there is a free version. Any case, all right. So let's see what's happening here. All right. So this KDS Media Video is my local workstation. This is Azure. I created a VM, a Linux VM under Azure to work as a server. Although in this environment, a server can be a client can be a server, a publisher can be a subscriber, and a subscriber can be a publisher. But if I look at this, so this is OLTP 2.0 is the name of the server, and I have a directory on there, and I have a message _ server directory, and I ran this. I set this all up ahead of time because I don't really want any issues, but I ran, this is the Go program that basically starts up the listener. You just give it a couple parameters. You have to give it the private IP address. I did discover when creating Linux VMs on Azure that if you stop the server, it actually generates a new IP, a new public IP address, which for the purposes of this demonstration would be helpful. But so this is, and you can see I've already sent a message because I tested it earlier. So hopefully we'll be able to send some more. This server here is OLTP 2.0 East. This one up here, the top one, I think I specifically picked locations that weren't near me. This is like a West Coast server, and then this is an East Coast server. I should call them servers, but they're really hubs. And the parlance I'm trying to use, or even a member would probably make more sense. But again, I started it, I went to the directory, ran the Go program to start up the listener, and it tells me that the message is listening on that port. Like these two. This is my local workstation here in lovely Evanston, Illinois. And it is, probably got a lot of these because it's telling me that it's running, it's listening. It's the client actually. And this is just listening for me to make a change to the database. And then it's still running, as you can see. So I'm going to let it keep running. And all I really should have to do is enter an insert. This is the PostgreSQL prompt, and this is the name of the database, OLTP 2.0 _control. And this is the table that I'm hoping this kludge will populate. In any case, let's get some data to insert. I have some inserts here. I already did the first one, Vancouver. Let's go to Las Vegas. So, all right. So what happens? You should see. Let's get this one up. Should see these all. Oh, I don't want to. I need the prompt back over here. Yeah. So it worked, which is good. So you can see It hit the location on the West Coast, it hit the location on the East Coast. And if I go here and I select that, it should be there. There's my Las Vegas entry. Should do one more. Make sure it works. Lebanon, Kansas. Trivia question. Anybody know what Lebanon, Kansas is? No answers?
I was going to say federal penitentiary, but I think that's Leavenworth, Kansas.
Yeah. No, it's they consider the geographical center of the United States. There's a
I
flag
did not
there.
know that.
Yeah. So I keep go back here so you can see the messages that come. I print the message as it comes across, so that makes it a little easier. So yes, so we're here. I forgot to go back here, but you'll see it at the bottom. Did it come through? Yeah, it's down there. As you can see, I have two tabs, and this tab is running the service, and this tab is just a session to the database. So on this database, you should see Lebanon, Kansas. You should check here, I suppose. Oh, there we go. Lebanon, Kansas. So it comes back. So, you know, it's a simple process. I mean, I would say, here, this is a good question for Jared. How would you do this in SQL Server? Yeah, I know.
I mean, you know, so SQL Server does have peer-to-peer replication, but it uses the transactional replication to do that. It's basically transactional replication from publisher to subscriber, and then the subscriber, you set it up as a publisher and go, and then you have to handle your own conflicts.
Right.
So that can become pretty difficult. So I like the control plane. You know, if I was going to do this in SQL Server, you know, and do it like all SQL, I would set up the bidirectional or the peer-to-peer replication, and I would give my, you know, my tables like identity columns with a seed that's like 2, if I had 2 of them, and I would seed mine starting at 1, 2, and the other one I would do it like 2, 2, so that the IDs never overlapped.
Right.
But you know, and so that there's kind of hacky ways to do it, but this is much more elegant, I think, by having that control plane, because that's really what you need, right?
Right. You mentioned a point, which is SQL Server replication, transactional replication is physical replication. This is more logical. So, I mean, it works similar, but you would be hard pressed. Well, but you couldn't do. Keep in mind, it's also sort of a master slave type replication. You can't have a master, but you can do in some databases. You could actually do it in Postgres. They do have a master to master type replication, but trying to manage that, but it's all physical stuff, just moving big files and moving transaction logs, and it's not message based, and it can be asynchronous, but not easy. But then again, we get back to square one with SQL Server. You couldn't give everybody a SQL Server database. Oh, you could. I mean, I guess the salespeople at Microsoft would be elated, but you'd end up, if you had 50 workstations that you wanted to try to do this on, you'd have a, let's see, probably a standard edition at say $1,000. Yeah, you'd be talking about $50,000 worth of licensing fees.
Yeah, I mean, depending on what you're doing, because you could potentially use Express for this too, for that, right? So,
well, the problem with Express again is that you've only got 2 gigabytes with RAM. You also have only 10 gigabytes.
Yeah.
Of storage. So, and it doesn't tell you when you get to 10.
Sure.
Yeah,
it just stops. It stops. So
that's the big problem.
Right. And 10 gigabytes, and I mean, is not that much anymore. It used to be a lot. Right. So, that's why open source certainly makes this type of approach, obviously, attractive.
Well, I have a question.
Okay.
What happens when you have a server that goes out? Let's say you lose Vancouver or Brooklyn or something.
Right.
How's it play catch up once it comes back online?
Well, keep in mind that all the members in this network have copies of the database. So I think it would be relatively simple to restore from another server or another member or at least to get caught up. So it would be a relatively, I think, straightforward process to get to that point. Does that make sense?
When you have, well, yeah, but wouldn't to do a restore? I mean, wouldn't you have to wait till everything is offline in order to get that done?
Well, that's if you've lost everything. I'm assuming that if you go out, you get back up and you just have to catch up to where you were.
Well, I'm talking about one server where it has gone out. Now it's back online, and it just has, let's say, information is 2 hours old.
Right. Again, I would still say that you could use one of the other servers or one of the other members to get caught up. Remember, we're talking eventual.
Right. I mean, in this kind of scenario, kind of everything has to be eventual, right? Yeah. Especially when you start scaling up, because that's the other thing, right? You can't, and you don't want to pick one particular server to quote back up and restore. You really want to try to sync versus backup restore, because which one do you pick?
Well, geographically the closest.
Yeah, I guess if you, but then you still got to sync. So
yeah, absolutely. So I mean, just to get synced up for a few minutes versus for 2 hours with the work versus a whole server going. If the whole server goes out, you're going to end up having to basically build it and restore from another location. And you're not going to. And yes, and there will be a gap potentially, but I think it's all manageable in this scenario. Go back to, as I said, there is a way to do this, to do that, Ross, what you asked me, and it might require some type of queuing, which it doesn't really have at this point, but you could queue up all those changes. So yeah, so I'm saying eventual reasonable data consistency.
Mm-hmm.
With a queuing mechanism, that would probably be even easier to do. But right now, there really isn't a queuing mechanism in place. But you know, you could add a RabbitMQ or similar to at least queue up all the. You know, 2 hours would be more of a restore from another member.
Mm-hmm.
And then queue up all those changes in the interim and then apply those. So yeah, so it's definitely it's doable. It's just obviously not there right now. Any other questions? See, I want to go back to, let's go back to here for a second. Maybe, how are we doing time-wise? We have 49, we have about 15, 20 minutes. Is that right? Is that what I'm saying?
Correct.
All right, maybe we'll just take a look at the, we'll pop the hood. And what I'm going to do is go to GitHub. Let's see. I've got my screen reorientated here. Okay. Yeah. Let's go here. So this is the source code and all of the data definition languages here. So this is probably, let's start with the client. And you know, actually, let's go backwards. Let's start with the database. Basically, it's similar to Transact SQL. As part of the process, you can see that I basically create a couple of databases. The one that I'm working in right now is the control database, which is really just what you need to sort of manage everything. There's a few schemas. Register, I was thinking would be for potentially transaction data in your application. And even possibly having a regional version of that register. So although things have changed since I created this, so then I would and an archive. So it creates those. This is these are the tables that I'm using. I'm not using all of them right now, but the ones that I showed you on the ERD, the route map, again, kind of looks a lot like Transact SQL. It does require the semicolon. This is the route map location. This is that hub group. I'm using a primary key. And there's some foreign keys to my location table. And that is really about it. I created a few other ones here that I'm not really using right now. Alternate routes. Functions. Okay, so this is a function. Functions and stored procedures in PostgreSQL are a little different than in SQL Server. The primary difference is that PostgreSQL, a stored procedure will not allow you to return data. You can insert and send parameters to it, but you can't really return anything yet. You have to use a function to do that. And this is the notify function, actually. that I'm using to send to Go. That Go picks up to send the message to through gRPC to those other servers. And it's all pretty straightforward. And I am using a little JSON. I'm using a little JSON to pass the data to Go. It was just simpler than trying to do it with gRPC. And since the server and the it is basically on the same bus as the client in this case, it's not a problem. And anyways, I'd still would have to have some kind of definition in there, data definition, and with the name of the column and the data. So why do it as a CSV? So I used JSON, and there is a JSON data type in PostgreSQL, and I use that to then send the notification, which it sends the name of the table it's coming from, and it tells you it's I think this is like insert, and then this is the name of the data, and then it sends all that, sends the notification. And then I put a trigger on that stage table for the location data. And that trigger and here's the trigger that fires off. This is the actual trigger that fires the insert. Oh, you know what? I think this. Actually, I take that back. This is a second one. This is the one that actually is in use. It's just a repeat. This is just a repeat. I'm trying to figure out what I did. So this is the function that sends the message, and then this is the actual trigger on the stage location table. And it basically just does an insert. Anytime you do an insert into that table, it then executes this function. And then that function is picked up by Go, and it sends it over a gRPC connection here. I don't want to go through all of this. I don't want to go through all the Go. But I'll try to summarize what's happening here. Go has its roots in C. So if you've ever worked if you're old enough to have ever worked in C, there's a lot of similarity. But this is the listener this is actually this is the Postgres listener, actually, that listens to listens for the notification, and when that notification fires the trigger, it then fires this gRPC message. And this is all the gRPC code. It can get a little gnarly, but it's I mean, this is all it took for me to pass that location data from one location to servers. As I mentioned, I'm shuffling the IPs, which was a thought that in some financial systems, like a trading system, you might want to do that. It provides a more level playing field for people who are receiving the data. And then this is the query that this is the query that the client. Oh, this is just the connection. This is just the I take that back. This query actually runs to look up the IP addresses. So basically, the best way to see this is to actually go to the main function, which is where it starts. So first thing I do is I grab a connection string, and it calls this DB get connection string right here. And the reason why you're not seeing my password in here is because I'm using an environmental variable in Linux, which can be encrypted, which makes it a little simpler than some of the crazy ways you have to do it in Windows or wherever. But so I have an environmental variable that I set, and then it looks up those variables, and including the password, and then it creates a connection string. So that's the first thing I do. I get the peer group. So then I go to the database and I get all of the IP addresses. Now you think, well, what happens if you're going to use this again? And there are ways to do that where you can maintain those IP addresses and reshuffle them, and even gRPC has the ability to know that that gRPC connection has been made. So that's a real plus. So that's it. So that's basically what happens. The listener is waiting for something to happen, which is a notification from Postgres. And from there, it goes, to use a bad pun. On the server side, these are imports, by the way. The like includes in C#, and they bring in code that's been part of the core Go system, or stuff that you might create. This, you can see, is bringing in the proto buff, which is the gRPC. It's like a template that has the data definitions in it. And from there, and I'll actually show you the contents. It's not much in there, but it maps it to to that location table. So here, let's go down to the end. Basically, here I'm just I'm looking at the oh, this is when you start up the server service, and it looks at the command line. But what it basically does is just goes through all this and starts running the service. And once the contact is made, once it receives a notification. Now this notification is through gRPC. Once it gets the gRPC notification, it connects to the database right here. And then actually, it then runs this stored procedure, which adds the location. And then there's a message that's sent back to the calling program, which comes from right here. You can see this notification is it's like an array. I call it a slice, and it has my message and the data. And this one has the return, and then when that return gets back to the local workstation, it tells it to update the data. So you could have multiple layers here if you really wanted to. If you really want, it's like in the old days doing a two-phase commit. You could send a message back to the server, you got it, and then send another one to commit it and all that. I'm not doing it for this demonstration, but you could do that. So that takes the proto buff, which is kind of interesting. How are we doing on time? We're almost done. Yeah, you're going to see. Oh no, we've got about 7 minutes. Okay, so this is the gRPC stuff, and it can be a little confusing, but once you get your head wrapped around it, it makes sense. But this is what's in that protobuf file. It's got a .proto, and it's basically a text file, but it's a template. And these are the data items that I'm passing as a message. And this is the return message that I use to send it back to the local workstation to tell it to finish updating. And that's, and you can get fairly complex with this stuff, and it could run on for pages, obviously, if you have a lot of data messages. But this is just a simple. I'm sure the one got you with this protobuf stuff is that with it comes a compiler. So if I make changes into this right now, I have to run everything through the protobuf compiler. And basically, that's because gRPC works with all sorts of different programming language. C#, Ruby, Python, some I've never heard of. It goes on. So it gives you a lot of flexibility. But once you create this protobuf, you have to run it through a compiler, and the compiler, I'm obviously using the one for Go, generates all this. This is the stuff you don't want to ever edit, because this is what it edits. So that is in a nutshell how gRPC handles the message. And I haven't done any benchmark type testing, but I have seen in the neighborhood of 7 to 10 times faster than a conventional REST application. So it's it can be useful. Let's see. I'm gonna do this. Wait for a second. I'll finish up. I mean, so use cases for this type of design pattern, and it really is a design pattern at this point, for like data distribution. Again, in a BI type environment where you might have a lot of power users out there that really should just be running things from a database as opposed to doing crazy stuff over the network. So this approach could be a solution. Same thing for event notification. And also, on a more advanced level, since the idea is to make it asynchronous, is you want to go after those applications that do a lot of polling. I've seen that a lot over the years. There's way too much polling going on in database applications. And so to get away from that, again, you have to kind of move towards an asynchronous messaging. And you also have to go back to the source system. That sometimes dictates what happens downstream or upstream. In any case, that's the presentation in a nutshell. The two things, as I said, we've been on GitHub when I've shown you some of those. I've shown you the code, and the README on GitHub, if you aren't familiar with it, is pretty, that I put together, is pretty detailed. So you can install GitHub. Well, you could install the everything here, and I can do it now in about 15 minutes. And some of it's scripted, but you could easily create a bash script to do this. But you can try this out. I haven't tried it out in Windows, but everything that I mentioned here will run in Windows. So if you do that, let me know what happens. You could create a Linux Docker in Windows too, and run it, which would be kind of cool. Although in production, I'm not sure I would want to do that, but it's possible, I suppose. And yeah, the other thing I was going to mention is I put this project on GitHub sponsors. So it's basically a way for developers to get paid to doing these kind of projects. And if your company is potentially looking at a emerging technology or wants to do a proof of concept type project like this, GitHub sponsor is a good way to go through. So, and I'd be happy to talk to you. So if there's any interest out there, please let me know. Oh, you know what this is? Is it 7 o'clock? This is all the, this is all, can you see this running? This is my my first project.
Yeah.
This is the COVID-19 data stuff running. It's going to these, it's going to the New York Times, and it's going to the other site that I'm using, Our World in Data, and it's downloading everything. So in any case, yeah. So and this is just PowerShell making REST calls to go get the data and bring it back. And I load it locally, I clean it up, and then I output it now as a CSV and JSON to the GitHub site. So if you're looking for any data, it's a little bit cleaner than the stuff you get from the New York Times and the Our World in Data. Our World in Data, they put in data that doesn't make sense. They add country codes and stuff that aren't real country codes. So I told them it wasn't a good idea. So I just kind of get rid of that. But in any case, if you go back to go back here and look at this project, data, you'll see that this is from yesterday. So these are the files that I'm generating in about 5 minutes. They're going to come back up here, and they should have today's date on them. And if you look at it, oh no, I don't want to see this. It's gonna. Oh, I'm going to hang out. No. Oh, in any case, so yeah, so these are. If you go back to here. And you can see everything about the project, and then if you go to the data, you can see it gives a map of all the data and what's in there. So it describes the data. I think the daily stuff has CSV and JSON versions. So if unfortunately we're still tracking this stuff. So in any case, any questions while this runs?
I think you have everybody spellbound.
Yeah, interesting stuff.
It is.
And it's in the right setting, it's very doable. So again, as I said, if there's any interest in pursuing this, I am available to discuss and to develop proof of concept work.
Cool.
So
Yeah.
Trying to think any other questions before we sign off. If you do have any, you can. I think I left my my email on the.
Well, we've recorded this, but
Yeah.
are you going to share your slide deck with us?
Yeah, I will.
All right, thank you.
I'll send it. I'll send it to Jerry. Yeah. So if anybody needs my my email or has any questions, please contact me. There. Okay.
All right, thank you, David.
So that
Yeah,
was.
thank you so much.
Yeah, I hope hopefully that kind of gives you a sense of. I think it's as I said, I try to assimilate a lot of this stuff and see what I can come up with, and this approach I like, and this is not the first time I've done this. I mean, I've been working in asynchronous messaging for a long time, and any chance I get to do it, it seems to have worked out well. So consider that, and again, if you have any questions, please let me know. And Jared and Ross, thank you for the time, and we'll talk to you soon.
Yeah.
And thank you for your time. Really appreciate this, David. Thank you.
Okay, great. Yeah.
Well, before we sign off, I forgot to mention that next month, September 9th, is our meeting. Karen Lopez is going to be speaking about migrating databases to Azure. So,
Woohoo!
what's that?
I said woohoo!
Oh, yeah. Yeah, it's a popular topic these days.
All right, great. Well, thanks everybody. Ross, as always, good to see you. David, thank you for coming. Great to have you, and take care, everybody.
All right.
Thanks.
Everybody.